Today, I want to share an update on the automation of our race director, focusing specifically on the computer vision and the vision scoring. I have a little proof of concept that we put together I want to share with you. So here we are looking at the code. Basically what I'm doing here is I'm using YOLO, which is a well-known computer vision, you only look once, computer vision for object recognition. What I'm attempting to do is, can we analyze a SimRacing video using computer vision to determine when there's action on screen. So what I've done here is I use Copilot to help generate this piece of proof of concept code. All it's doing essentially is loading the YOLO model into the CUDA, so that we're using our NVIDIA GPU to do the work for us. I've got some configuration for overlaying a chart, which is purely in this proof of concept so we can visualize what's going on. And then we load an input video and we're going to produce an output video. So as it runs, it goes through and it creates a score for each of the frames. I'm not going to let it run the whole time, it takes too long, but we'll take a look at the results. Okay, so that video's finished processing, and I want to draw attention to a couple of areas here just so that we can take a look at it together. If you notice at the start of the video trace, there's a lot of activity. This is the start of the race, so there's obviously a lot of cars, there's a lot more activity going on, so that's why you're seeing a lot of activity there. Then things quieten down a little bit, and then there's some more activity. What I want to do is actually take a look at, a couple of the spikes, and let's see whether there's something interesting. So there's a huge spike sort of midway through the video, and then there's another huge spike towards the end. So what I'm going to do is I'm just going to play those pieces so we can take a look at them together. I think you find it's quite interesting to see. So let me cue those up, get those cut, and we'll take a look at them. So this first spike was actually caused by the car that was passing. It closed right in front of me, so it filled up a lot of the screen, and that's why you can see the spike in the activity there. There's also an interesting false positive when we go around the next corner here. You can actually see the cars on the left that are picked up as we go by, but they're far enough away that it doesn't really affect the score as much as if they were on the track. And the second area of interest was actually the race ending event. It was the crash at the end. So there was a little bit of action leading up to the crash, then the crash itself, and the view from the pits where there was another car. So that was a little look at our POC of the computer vision. I think it looks pretty good. I think combined with the other activity data that we can get from the voice activity and the telemetry data, I think it's going to be a really useful tool to help automate some of the workflow. And just before I leave, I wanted to play the actual clip that I was showing there, the race ending event. Watch out for the BMW. He's on the left in front of me. He's backing up. I go left. He decides he's going to drive back across the track, kills me, kills another guy, and then starts yelling at somebody else and blaming them for it. So, if you're out there and you have an accident, just because you had an accident doesn't give you the right to take everyone else out as well. So I'm going to leave it with that little clip. Thanks for watching.
Watch out, watch your return, watch out, watch out, watch out, watch out, watch out.
Incident in, right chase, it looks like it's in tow.
You have got to be kidding me. Got to be kidding me.